All right, welcome to the NLP and Healthcare panel. I have two luminaries here. Catherine Havasi, CEO of Dalang Technologies and a serial entrepreneur. And David Talby, CTO of John Snow Labs, the company behind this conference, as well as the company behind the Spark NLP project. Welcome to the panel, folks.
Thank you.
Thank you for having us.
So first question, which is basically healthcare in general. So what makes applying NLP in healthcare particularly challenging? So at a high level, some people in the audience probably know kind of the stereotypical things, right? So like privacy regulations, but beyond that, so what else it really is challenging about NLP in healthcare? So Catherine, why don't you start?
Sure. I think one of the more surprising things that's a big challenge, and I think this is actually starting to be true across all of NLP as a whole, is evaluation in a lot of places. Evaluation is, I think, one of the bigger issues in NLP as a whole today, and healthcare is really not a big exception to that. If you think about looking at the differences, especially when we're talking about effectiveness in helping motivate patients, effectiveness in understanding what's going on in a doctor-patient relationship, evaluating some of those outcomes can be very longitudinal, and that can be very difficult. Like right now, there's a big push towards gamification in various ways in some parts of digital health. And, is that something that's going to be effective in the short term? Possibly. Is it effective in the long term? We don't know, because it's so hard to tell with what's going on with the longitudinal approach to evaluation, on top of all the regular problems that are currently happening in NLP around how do we do evaluation in flight? How do we keep people in the loop when there's privacy implications? I think it just gets pretty thorny.
So when you say evaluation, Catherine, just to clarify, you're not talking about simple evaluation of a model. It's more like, is this delivering some overall ROI, whatever the ROI might be?
What are the long-term outcomes of this, but also to some degree, what's going on with the model? I think this is an NLP as a whole. If we look at, let's say, text generation right now, and we look at the evaluation issues there, it's tremendous, right? Because the things that we see that are like the SSA techniques, the things we see that are getting good scores in text generation evaluation all have people in the loop, which doesn't work on so many levels for healthcare, right? And trying to figure out how do we evaluate these complex models while maintaining privacy is definitely also an issue.
So actually, David, she brings up an interesting point, because one area in NLP or text that is particularly popular but hard to evaluate is summarization, right? Because basically you have this body of text and someone gives you a summary. Well, how do we know which is the best summary? So anyway, any other challenges for you, or do you want to add on to what Catherine just was describing?
Yes, I definitely agree with what Catherine said. And I think evaluation is a huge challenge, because we can barely agree on how to evaluate, text generation, text summarization. But if you think about if you're building a digital health app and the goal is to help me, manage my diabetes or lose weight, the real question is, does the app help you lose weight? Right? It's not how accurate the model is, right? And that's really an open question right now for a lot of that space, right? So and really the question is, okay, if I can move an F score from 85% to 95%, it's like, really, so what, right? And we are still at that point. But other than that, I think one of the biggest challenges in healthcare and NLP in healthcare is that, it's really not one language, right? It's each subspecialty, each context are very, very unique, right? And if you think about it, if you want to, to be able to understand how to read and write radiology reports, that's a career path, right? That's not even a 3-month course. That takes you several years until you can understand that, right? If you're an oncologist, even a dentist, right? It's its own language, right? So for example, if you give summarization an example, all the summarization models that we use to say summarize news article or Wikipedia are completely irrelevant for healthcare, right? Because if you ask a dentist how do you summarize this patient, right? It's not a summary of the paragraphs about the patient, right? I need to know, look, really, why are they here today, right? What's the one or two things that I need to know about their history, right? So, smoking, past pain, and are they on, specific medications, for example, right? So one of the big challenges is that all of these are super domain-specific questions that really require someone to, they require a specialist, and you need to see how you actually train those models. And that's not data that you can easily kind of crowdsource, right? Both for privacy reasons and because really you need specialists in order to provide the training and measurement.
So, Catherine, so healthcare it strikes me as you're dealing with people who are experts in very complicated topics, and the text itself that you're dealing with is probably also very specialized. So, my perception as an outsider is that then when you build these models, you really need to work closely with the subject matter experts, probably more so than in other domains, right?
I mean, I don't know if it's necessarily more so than other domains. I certainly think that there's a lot of jargon in medical text, and depending on the text involved, it can be so dense that even a technique like a fine-tuning or a transfer learning can't pick things up because there's not enough normal language in there. When you're looking, David brought up dentists. When you're looking at something like a dental notes, that's a whole different language, specialists, things like that. And there's not that much English in there to grab onto it. It feels like an entirely different language. And at that point in time, you have to start almost thinking of it like that. And that becomes very hard. And a lot of the techniques and models, even ones that adapt to particular domains, can be very, very difficult. And of course, a patient is going to speak a very different language than a doctor about the same issues, right? So a patient who is talking about a particular medical condition or a caregiver who's talking about a medical condition is going to use a different language than the doctor is as well. And aligning that and taking that into account becomes very difficult. When you're working with things that are a little bit more English-centric, I think we've certainly had luck being able to use fine-tuning, transfer learning in working into those areas. But once you get into specialists and notes and clinical papers, it really becomes quite dense.
So you both have built and deployed NLP pipelines and models in healthcare settings. So how do you convince the end user that whatever it is that you built is ready to go? I mean, after all, they are the subject matter experts, and you're probably trying to automate some things that they're doing. So, what's the process for deploying something in production in healthcare? David.
Sure. So I think at the end of the day, it's not that different from any software package that you're building, right? In the sense that if you look at kind of really best practices of product management, understand your users, interview users, what does the user, what does the user interface need to be? What are the workflows, right? And what you need to build.
But your users all have advanced degrees.
Yes, exactly. So yeah. So here's the challenge. The users, exactly, not only do they have advanced degrees, they've been doing this for 15 years, right? Or 20 years, right? And because of what happened with EMRs in the US, they have very little trust.
Mm-hmm. Oh, what happened? Can you give us, those of us who aren't familiar with this? Yeah.
So if you remember in the 80s, finance moved everything from paper to computers, right? And then one of the things that happened that had a lot of impact on other things, the software industry, is that the first thing we did is we took the forms that we used to have in banks and we said, oh, we just have them on the screen. Right, and that turned out to be a horrible user experience, right? And if you remember, there was this whole really decade and a half where we had books like about just how horrible user interface design, computer design were, because they really were, right? And the first generation of software made people slower and worse at their jobs. What happened in healthcare is that the U.S. government gave a lot of subsidies and required by law hospitals to move from paper to electronic medical records. Okay, and the electronic medical record systems, basically the requirements documents for the software was check all the boxes so we can get the government subsidy. Okay, as a result, doctors now spend 2 to 3 hours a day
Oh.
Feeling in, just sitting at the computer.
I have read articles about this.
Yeah. The level of burnout and dissatisfaction of doctors in the US is at a historical high. It's its own epidemic. And there's just a lot of anger at the EMR companies, at the government on the way that this was done. Okay, because really there's almost a consensus that we are, that as a doctor, you were better off when you were doing things in paper. You had more face time with the patient, right? Just less bureaucracy and less overhead, right? As a result, right now, here's the environment. When you come and talk to a doctor, right? Say I'm whatever. I'm a pathologist. That's my job. Okay, my default stance is I'm already super busy. The last thing I want is another alert on another screen to look at. Okay, and the last few times I talked to a software person did not turn out that well, right? So that's kind of where a lot of the industry is at. Okay, so what you need to do, really, the same thing that you should do when you're building a dating app, right, or restaurant recommendations. Start with how does the screen need to look like? What does the person actually need to see, right? With the actual attention span, right, the context, all of that. Okay, and you really want to go backwards from there. Okay, so what you see in a healthcare setting, yes, you have specialists. Okay, they don't want something flashy or nice. They want something that really shows what they need, right? And yes, it's super context specific and super, right? So what's relevant for patient on bed 16 and patient 17 are completely different, right? Because of the context, right? I don't want you to tell me the entire story, right? So you tell me a summary of the patient. That's bullshit because I just talked to them this morning, right? Tell me if something changed, right? Tell me something, right? And if you just give me one more alert, look, I already have 200 per hour that I ignore. Right, so that's its own problem. The other thing you do is, yes, you cannot tell them what to do. You have to explain, right? Because if you think about it, you're a doctor and you have patients, right? If a computer system tells you, oh, this patient, you should switch him for 20 milligram to 80 milligram, right? I mean, you immediately respond like, what the hell? This is my patient, right? So what you need to explain why.
So to clarify, so Catherine, model explainability, is that what he's referring to here?
I mean, absolutely. And I think that, to be honest, I think a lot of the problems that we're seeing and that we just talked about are in applying NLP everywhere. And I referenced some of that in my talk. I think model explainability is hugely important here. I think usability and provider or patient-centric design is huge here. And I think NLP holds a lot of...
Which, by the way, Catherine, I think a lot of ML people don't actually think about UX at all. They think that's someone else's job. They know nothing about
changing.
UX. Right? Yeah.
Maybe I'm an optimist. I think it's changing, right?
Yeah.
I think people are starting to realize that. I mean, I think, in the last year, things like ACM's IUI conference ended up, I think, selling out because there was just so much interest in the intersection of usability and explainability and AI. And I think we've started to make progress here, but I think across NLP, NLP in some degree, like the user interface between the two of us right now is us talking to each other, right? So it's kind of very hard to separate language from usability. And I think that means that's something where, as NLP folks, we hold the key to potentially helping solve this problem in healthcare.
So by the way, let me ask you, since you are doing some teaching at MIT these days, so you say it's changing. So does that mean that data scientists and machine learning people are now required to take JavaScript?
That I don't know. I don't. When I teach, I only teach like entrepreneurship to undergrads. I don't teach undergrad CS classes, so I really don't know what the curriculum is, and I'm forever surprised by how it's changing, to be honest. Every time I interview potential undergrad students. But I think there's just really much more of a consensus within the AI community that we need to be thinking about usability. And I think when papers are reviewed in the academic world now, there are questions that come out to explainability, there are questions that come out to usability. When people have thesis defenses, somebody will ask these questions. And I don't think that was true a number of years ago.
Speaking of which, David, and this is true for almost any machine learning application, I think most companies and product managers undervalue the fact that UX can actually help you improve the model. In other words, if you have a good UX, even in NLP, if it allows the users to help you spot errors in your model or suggest where your model can be improved and so on and so forth. That goes a long way towards improving the user experience, but also the underlying model, right?
Oh, yes. Yeah, I think one thing that we're really just starting to see is yes, look, let's say if I concluded the fact, so let's say I looked at the patient rectal and said, look, this patient is a smoker, right? And you say, why? Oh, I'm highlighting the facts. I'm just highlighting the word, for example, that's how I explain. What would be super useful is if the model got it wrong, come said, no, you got it wrong. This is under family history. This is not under patient history, right? It's not the patient who's a smoker. What you really want is a way for the doctor to explain it back to me, right? And people will not just do it for explainability, right? The same thing, if you go on Amazon and they show you results, you don't click, was this useful, yes or no. You just either click the link or not, right? It needs to be part of your regular thing, right? So what you need is to design UX so that, look, if I got it wrong, it's like 2 clicks, you corrected it, right? You correct it for yourself, right? Because you need to know where to take this patient next. And yes, and we can route it back to the model, right? Because now we know, oh, look, this is actually a negative example, right? And here is why, right? Because you highlight another thing that said it. And especially in those cases where really one of the challenges is to draw drawing for knowledge from domain experts. I think there's a huge opportunity here.
So, Catherine, you mentioned that explainability is a hot topic now. The other hot topic, of course, is fairness and bias. So we don't talk about that as much when it comes to NLP, because I think most of the examples people read about are in computer vision, right? So are fairness and bias also big problems in NLP and NLP in healthcare?
I would say absolutely. I think in NLP as a whole, it's definitely something where we definitely can tell that there is model bias in the big models and the smaller models. There's been a lot of work on that topic. I think that there's also been work proving that sometimes downstream processes, even if you debias a model, will add bias back into the model. There's a great paper on that. And I think it's a big question. One of the things that makes me confident, well, optimistic is the right word, is that I think there is significant awareness of this and there is work being done towards it. The third thing I would say that's a big issue around sort of NLP and healthcare, I think it's talked about less, is privacy. And the reason why I'm less optimistic about privacy than I am about bias is because I see a lot more progress towards bias towards resolution there than I do towards any kind of resolution on the privacy issue. So that one does scare me more. But in NLP in general, we see it even in my previous company, which was not in healthcare, Luminoso. We would see it when we started seeing model bias. It was things like being more willing to recommend a Italian restaurant than a Mexican restaurant on basis. And then when we noticed that, we spent a lot of time debiasing the model. And some of that has flowed through to ConceptNet as well, which is spending a lot of time thinking about that. And I know my co-runner of ConceptNet, Robin Spear, does a lot of writing on that as well. So I think there's a lot to go, but I think there's, again, more awareness there, whereas privacy scares me a lot more.
So what are some canonical examples of NLP bias in healthcare? Because computer vision, we have many known examples, right? So I imagine maybe not NLP, but maybe in speech technologies, maybe the software is not as good as picking up foreign accents.
If I can actually answer, I'll talk about a very specific example that we're dealing with right now. One of the things that we're looking at is we're looking at conversations between doctors and patients. And we're modeling those relationships and conversations to really understand what's working and motivating with a particular patient. There is a lot of bias in healthcare, and there's a lot of bias in the way doctors treat patients. And so it's a pretty active area of conversation. How are we not going to just pick up that bias when we're trying to model these things and carry it over into any kind of automated system for doing behavior change for chronic disease management? We don't want to do that, right? And so any kind of AI picks up the bias that you see in the data that comes in. And if that bias is pervasive in places, then it becomes really hard to say, well, how are we going to make sure not to pick that up?
So David, you're building software, NLP software for healthcare. So is bias one of these things that your software guards against?
Well, the process that we follow guards against it. I don't think there's no, there's no flag in your model training that can fix bias, right?
It's ethics. So
exactly.
There's no checklist
It is
for ethics. Yeah.
Exactly, right? So the question is more about what's your experimentation process, right? And what's happening right now is that, first of all, I think we're very early on, right? So the thing, even a lot of just remaining academic work on how to even evaluate it, right? So the reason we know there's a problem, and if there's one thing we can learn from vision, is because we know there's a problem in the real world, like Catherine said, right? So we know, for example, look, if you're a black person in the US and you get sick with cancer, okay, you will die faster than a white person, okay? Because there's a whole set of cultural and systematic issues, okay? So if we learn anything from computer vision, if we just take the data and train a model based on that, we are going to do that at scale, right? We're going to just reproduce the problem. The question is, how do you go and prevent that, right? There's also, by the way, issues with one of the well-known issues with women, they get less pain medication. Okay, either just they complain less, or they get listened to less, right? And it's one of the things that's a combination of a whole set of cultural, systematic, procedural, clinical issues. So it's definitely an issue. One of the things that we do today as part of the process is for example, look, you have a model, and your model is whatever X% accurate. Okay, now just how does it work only on women, only on men, right? How does it work only on Asian people, black people, white people? If you're working within cancer, how does it work in people from different stages, right? And in healthcare, by the way, sometimes you can be biased because there are medications. I mean, there are medications that are in the market. Kind of say, look, this medication, works for 60% of women and 40% of men. Okay, I mean, we're not going to prevent it from being in the market, right? Because it saves some people, but you need to know it. We are starting to see, really in the past, I'd say 2-3 months for the first time, I'm starting to get contracts that actually require us to follow these processes from some of the pharma companies, because they're already foreseeing the lawsuits 5 years down the road, right? So part of it comes and say, no, it's like, you have to show us that you have this process, you have to document it. So I think because it's healthcare, because we learned maybe a couple of things from vision, the hope is that we're tackling this early on.
So, Catherine, you mentioned that you're not as, I hate to put words in your mouth, optimistic about what the community is doing in the area of privacy. But on the other hand, there are people working on privacy-preserving machine learning techniques. Mm-hmm. So what aspect of privacy and NLP are you worried about mostly?
Oh, that's a hard question. I mean, I think, so to go to privacy-preserving machine learning, I think it's fantastic. I'm really actually quite interested in this. This is a side interest, and as surprising as that is, the math of transfer learning and the math of privacy-preserving machine learning are actually really similar. So it's much closer to my research area than you would guess. It's just the way it comes out. And because I care about privacy, I care about that. So I think that there's a lot. I think that's in its very early stages, right? If we look at the potential there, I think there's a huge amount of potential for something like that to be able to deal with situations where there's simply not enough data, especially in rare diseases and other sorts of issues. And so I'm really happy that that's going on, but I don't know at what point we can be confident enough in it to say, hey, now it's ready for prime time. I know it's not now, and I've taken a pretty good look at it. To do something like that at the level that it would need to do something like a drug discovery pull at a bunch of different hospitals. I think it's an interesting question. And I feel like, the part of it is also, and I'm not going to get into this here, but part of it is also the way we think about privacy is so different globally in each different jurisdiction that getting consensus is going to be really difficult, right? It's very easy to get, hopefully very easy to get into consensus that we don't want bias in AI, but it's very hard to get consensus of what privacy means. And I think that's sort of the crux of why I'm more optimistic about one than the other.
Yeah, actually, as you were talking, I realized even the people working on contact tracing, they have to be very careful in terms of how they actually report the results, because even if you start reporting the results even at a zip code level, that may not be enough privacy protection for people, right?
Yep.
depending on the jurisdiction.
Yep.
And you think of all of these organizations asking the COVID questions and whether or not they've ever thought about the privacy aspects of that as well.
So David, what NLP use cases are you most excited about that you think are still just in the early stages? And for our viewers out there, obviously they're aware and read about all of these fantastic news stories about what's happening in terms of transformers and all these massive models that are based on deep learning. But when it comes down to it, we're talking use cases that are realistic in the next 2 to 4 years. What are you most excited about?
Yep. What I'm most excited about are cases where people actually took technology, applied it on real patient at enough scale, so you can actually do some, get some significant result and see what happened. The two, for my own subjective view, the two most interesting studies so far are both from China. It was one paper where a system was actually used to diagnose patients as they go into the ER. And this was a children's hospital, so mostly parents coming in with kids. What was interesting was that this system was used for over 18 months to diagnose over 600,000 children, okay, in an actual ER. And the problem to solve is really just the lack of having enough doctors and nurses to look at kids. And the end result was that the system was more accurate, and this was across, I believe, 90 different symptoms and diseases. It was more accurate than junior doctors, and junior doctors was anyone with less than 15 years of actual clinical experience. Okay, so basically anyone under 40, which is a very high bar to reach. So for me, that's one example that says, yes, like forget transformers, forget transfer, forget the academic pieces. This is like actually diagnosing people at a very large scale, right, on real data. And this is, parents with small kids, right? So this is not nice, this is not nice like Wikipedia, edited article. This is real world data. That was one very interesting result. Mm-hmm. The other one also from China from 2018 was that was the first time, and I think this was repeated this time also in Japan, that an algorithm actually passed the state licensing exam. And what's interesting about it is that more than half of the questions in the exam are just patient stories, right? So it used to be memorization. They completely did away with it. Now it's mostly, here's a patient presentation. What would you do next? Right? Mm-hmm. So I think we are getting to a point where you can look at real language with real noise. You can look at a variety of things. So it's not those super narrow applications where it's only one disease or one symptom. And we're starting, and we're just starting to see the applications. Right now it's only research. So probably quite a few years until this becomes, more widely used. But for me, these are these are the interesting promises.
So we are in an NLP conference, but Catherine, let me ask you about a related field, which is speech. It seems to me that speech technologies, it's a no-brainer for doctors, right, to use. It probably relieves them of all of the complaints that David was talking about, EMRs. Maybe you just dictated all this information to the EMR. So to what extent is speech technologies disrupting healthcare?
So I am actually going to ask David if he has a better answer for this, and then I'll give it a shot. I'm not as much a speech person. I'm going to be honest. I'm going to be absolutely honest. I am not. I mean, I know speech outside of healthcare much better than I know speech inside of healthcare, and that's about where I am on that. So I don't feel like I could actually answer that question well. Sorry.
So yeah, I'm no expert in ASR technology, but here's what I can say: there are tens of thousands of people whose career is to transcribe what doctors are doing. Okay, so this is such an issue for doctor that basically, as a doctor, you pay someone full time to be either in the room with you or over the headphone. And there are several companies and startups who do this. Okay, where there's someone who's basically shedding your full time, so that you can sit with your patient face to face. Okay, when the patient leaves the room, okay, someone else has already written the encounter notes. The doctor says, oh, you ordered these medications. This was a referral. This is summary. This is next follow-up. You review it for 2 minutes. You press OK, or you tell them, oh, you need to please, no, this I meant, 50 milligram.
By the way, there's a huge advantage to that too as a patient. I mean, because that means your doctor's actually interacting with you.
It's actually with you. Yes, seriously. No, and look, I know if you've been to doctors in the US, right? Really, more than half of the time they're actually at the screen and keyboard and not looking at you, right? And that is immense, right? Because really, if you think about that, your only value is that direct face-to-face interaction. I mean, you drove all the way there, you got there, right? Is the physical connection, right? So the problem is so bad, right? Really, tens of thousands of people are now working as transcribers, okay, manually, right? So obviously there's a huge opportunity, right? Because people are paying, $50,000, $100,000 a year to do away with their documentation, right? So not all doctors can do it, right? But doctors, many doctors say, look, for 2-3 hours a day, this is actually a good investment. If you can do it automatically, which today you cannot. Today people do a mix of NLP and human transcriptions. If and when you can do this cheaply and at scale, absolutely, right? You'll have the doctor just be with you, right? And you have this, magical AI in the background that does all the administrative work.
So let me ask Catherine actually a question about something I know that she cares a lot about because she discussed it before we started recording, which is knowledge graphs. So I love that topic as well, and I've been talking to more people about knowledge graphs. So why isn't knowledge graph as mainstream with data scientists and machine learning people, or is it about to become mainstream? What's your take?
I mean, I think it's interesting. There is often a lot of work that goes into building a knowledge graphs, and there's somewhat of an art to it. And I think that lately there's been so much progress in machine learning that doing something very manual, like working with a knowledge graph, can be a little bit of a turnoff. I think that it is going to become very important, and it's started to become very important because of the way that knowledge graphs and transformer models and deep learning models work together. In the pre-Sesame Street era of NLP, if I may call it that, when we were still at the skipgram models, we were right at the end of that era. We started seeing the idea of taking structured information and sticking them into a knowledge graph, often called retrofitting or X-fitting, really taking off at that last ACL right before it. And I think, and we've seen things like that go to market. I took something like that to market. And so building things like that for transformers, I think, are going to be very important. We see hybrid learning right now being a big area in academia, but I don't think we're going to really get to the next stage with transformer models until we find a way to incorporate structured information, both for explainability and also for, frankly, control of the model, and making the model, fixing issues with the model, and having more control over what it does and why it does it.
So for our viewers, Catherine, who are not familiar with knowledge graphs, if you had a great knowledge graph, what could you do with it? So what are the things that open up?
I mean, I think one of the big things that you can, there's different kinds of knowledge graphs. And in medical domains, it's definitely about helping cut down, it's about having the information already there, that you don't have to learn from text, and you don't have to learn in a way that might not be written down or might have mistakes in it, right? If you're just trying to learn symptom trees and things like that from a lot of information, you might run into a situation where you don't know what to believe. You don't know all the different ways something could be said. On the flip side of that, you also, patients are going to use slang, so you've got to learn some stuff from free text. So I think they work together really well. And I think that's a huge application in a field that we already talked about has so much jargon as well.
So David, you mentioned this earlier, but healthcare, I think, is particularly challenged with the amount of data, right? So either you have very few patients, or the disease is extremely rare, or whatever reason. But so what are some of the things that people do to overcome that?
Sure. So look, first of all, transfer learning, if there's one thing transformers did, is they significantly reduce the amount of data you need for a tuned model, right? So let's say I have kind of a generic, I have Bluebird or BioBird of one of the healthcare, biomedical models, but I need a specific question, right? So I'm analyzing radiology reports, of, say only, X-rays, and I want to ask a specific set of questions. What even in 2017 or 2018, I would tell people, oh yeah, you need to annotate 10,000 patients to get a good model. Now you can tell, oh, you need to annotate 500 patients, like to take about a week, right? And you have really a model that performs really, really well. And that's the kind of the bottom line effect of Transformers so far, which is great. The other thing is absolutely knowledge graphs, because one of the things that are unique in healthcare is that, in contrast to many other diseases, we actually have a full list of everything, right? We have the exact list of all body parts, all diseases, all symptoms, all drugs, all mental, really. And if you think about the whole work on ontologies and terminologies started in biology, right? And that's the one area in kind of human knowledge where we actually took the time to write down everything and decide on the name and the hierarchies and classification, right? So if you want to answer a question like, which patients are on an antibiotic, right? An antibiotic means like 200 things, right? But yeah, like there's a list, right, of what counts as an antibiotic, right? And there's a hierarchy, right? Or which people had, head injuries, right? There are hundreds of head injuries, right, from different types, right? But there's a taxonomy, right? There are relationships. You can answer those questions, really without any machine learning magic, right? If you have the right knowledge graph, you can just answer the questions, right, deterministically. So that's definitely a huge value add.
So let's close this panel by having you do something I'm sure you may not like, which is to make a prediction. So short prediction each. So let's start with Catherine. So it could be NLP, it could be healthcare. Yeah.
I mean, I think that we've seen a tremendous increase in the usage, the coverage, and the opportunities in digital health. I think we both did some of our own market research that put the number in huge numbers of percentages. I don't even want to say them. I think Accenture came out with something, HIMSS, I think, came out with a very big number. I don't remember what it was, but certainly in the hundreds of percentage increase. And I think and in some ways, digital health have been very blocked previous to this. And so I think even though usage might not stay at that level post-COVID, I think we've both unlocked the ability to innovate in healthcare in a way that we haven't previously. Healthcare has a lot of very old systems and a lot of very old practices, and a lot of things had to change very rapidly. And I think that's been very good for it. And I'm hoping that we'll continue to do that in the future, especially now that patients have seen some of what they could get if we had it together a little bit better. and hoping that continues to motivate the changes that need to happen to have that continue into the future.
David.
Yeah, so predictions are very dangerous. One thing that happens with healthcare moves more slowly than other industries, because you cannot just experiment with things. It's often just plain illegal for different reasons. And the systems are, the systems take longer. It's a more complex systems. But yeah, if I had to make one prediction, I think we're going to see huge changes over the next few years in the way we learn about how drugs and treatments work after they're in the market. Right. So if the model used to be, I do clinical trials and then we're good for 50 years, I think we're going to a much more continuous model. Right. And I think, even the discussion about the corona vaccine are there. Right. It's first we're going to make sure it doesn't actually kill you. Right. At least not quickly. Right. Then we're going to do some people, but really the model is going to be, we're experimenting on larger populations. Right. And you want to do it with everything, right. With chronic diseases, right. With cancer. You really see what works, what doesn't over long periods of time. And I think now we're the first time in history where first of all, we have the data electronically, right? We have your structured data, we have your NLP data, we have your imaging data for a large part of the population. We can actually do the tracking with computers. The second, the technology is there, right? On NLP, right, as well as imaging, right? We can do things that really until today, by the way, the reason this didn't happen is because, if you want to do a study on 200 patients, you have doctors who sat and read the patient stories one by one, right? Which of course doesn't scale. So I think we're going to see a huge difference in how, in drug development, right? And I think we're going to see many forms of treatment, and digital health being one form of such treatment, right? Where it's going to be much more of this is a continuous experiment to the population. We'll tweak as we go along.
And with that, thank you, David and Catherine, living embodiments and counterexamples to what my old friend Jeff Hammerbacher used to say, the greatest minds of our generation are working on models to make people click ads. Well, we just heard that not everyone is doing that. So thank you.
No.
Thank you so much.
Ben.
And with that, we are done. That's a wrap.